Let me now step back for a moment and explain how our kernel language approach differs from other approaches for defining how programming languages execute. So given a practical programming language, so there are in this view three general approaches to showing how they execute. There is, for example, the foundational calculus. This is, for example, something like the lambda calculus or the pi calculus or any of a number of mathematical formalisms that show the essential concepts of a programming language. These foundational calculi are usually simplified very much with a minimal number of concepts because this makes it much easier to prove properties, to prove the expressiveness. For example, proving equivalence of two paradigms or two languages using a calculus approach. So this is the foundational calculus approach. It's not so useful for programmers. It's useful for proving things, for understanding in a deep way the expressiveness of programming languages. Another way is the virtual machine approach. The virtual machine is in fact an implementation which is targeted toward a particular processor, a particular kind of processor architecture, something like the Java virtual machine, the JVM, for example. So the target here is to allow efficient execution on a real machine. So this introduces many concepts that are needed exactly for that reason, for making things efficient on a real machine. So we don't want to prove properties, we want efficient execution. So again, programmers will usually not use the virtual machine approach directly. And this leaves the third approach, which is the kernel language approach. So in the kernel language, you will define a small language which contains the concepts that are important for the programmer in reasoning and understanding about programs. So all the small languages we see in this course are examples of kernel languages. So you see the three different approaches. Each of them can be used to define the execution of a real practical programming language. Each of them is actually used. The kernel language approach is the one that's targeted toward programmers. The foundational calculus is toward theoreticians, mathematicians who study programming, and the virtual machine approach toward implementers, compiler writers, and virtual machine implementers. So these are the three approaches, and so now you understand where the kernel language fits in the general set of approaches of how you define programming languages.